The idea is to dynamically select questions based on the query, the image, and the previous responses from Computer Vision Detectors. So imagine that the query is to find all objects of the type of car. Now, and imagine that it is cheaper to label the segments than it is to actually run a costly object detector over many windows. So there are a number of image segments that can serve as context for cars. We want to label segments that are not only informative to labeling the whole scene, but also informative to the query itself. The goal is to reduce the search space over which we look for cars. So here we choose to label a road rather than a sky, even though the sky and the road are both equally large and would label as much of the scene. And this is because the road is more informative to our query of looking for cars. So we ask the question, where is the road? Our algorithm labels the road. And based on a context model, on a spatial context model, we can predict the typical location of cars given a segment of the type road. And this process can be, and this gives us a search area for the car. And this process can be repeated a number of times with other labels as well. So, for example, it's useful to know where houses or buildings are with respect to cars, because cars are often parked next to them. Right, so we can label buildings, and this reduces the search area for where the car might be, and we can have some process that somehow reconciles these various search areas to give us a much smaller search area. Once we are done with this process, we can then run the expensive car detector only in the refined search region that we found. So the framework models the problem as a Markov decision process, where we train a policy by reinforcement learning to decide what is the best action to take given what we have asked and what answers we have received at any point in time. We could either ask more questions, we can decide to stop and run the detector, or we can actually reject the image and say there are no cars at all in this image. One of the most important details about how for this model is how we model spatial context given a labeled contextual segment. Right, so imagine that we're looking for a boat here, and we have a sky segment. So we can look through our training set, we find where the sky is, and we find where the bounding box of the boat is relative to the sky. And after enough of these instances, we can build a spatial co-occurrence map that can be used for our model. So what's different from the standard co-occurrence model here is that we also want a co-occurrence model that varies spatially, not just for the environment as a value. And we can do this for many pairs of categories, like water to boat, sky to boat, road to car, and grass to cow. I'm not going to go into any more details. I'll leave those for the poster. The main conclusion is that we are able to reduce the number of object proposals that we need to look at in order to label various object categories while maintaining the state-of-the-art accuracy. And this technique can also be used to simultaneously detect and segment an image, and we perform reasonably well in images as well. So for more details, please go to the poster.